sigma notation. Sigma notation. So the thing with sigma notation is notation. The idea with sigma notation is that it is just brought in when you consider the sum of terms in a sequence or series rather. Sum of terms in a series. So the idea is a number pattern, right? Like 2, 4, 6, 8, going onwards. They will call this a sequence because of how it is spaced out. You see, the moment it has semicolons here, they call this a sequence. You see, this same sequence, the moment they just change it from having semicolons to maybe 2 plus 4 plus 6 plus 8 going onwards, they now call it a series, but they work exactly the same. You see, determining the next term, you do the same thing. Getting a general term, you do the same thing. You see, it's just a name that will give you an idea of how it looks visually. So when you're dealing with a series, you then are able to work out the sum of terms in that series. You see, so when you work out the sum of terms in a series, right, it all depends on how many terms you're adding up, etc. So before we even worry about sigma, you have to remember when you're dealing with a series, you still, if this here, you can consider it a an arithmetic series. You see, arithmetic, because there is a common difference. You see, it's arithmetic. So this being an arithmetic series, it also has a normal, the same general term. It still just has, nothing is different there. You see, the only thing that is now introduced is that they can, in some cases, ask us to work out the sum of the first 2 terms, 3 terms. No, that's too little. Maybe like 10, 8, depending on what they want. So in situations where they will ask that, you see, you need to remember that they will be needing us to use the SN formula. N over 2, close bracket, 2A plus N minus 1 D. So this is a familiar formula, right? Yeah. So the only additional information is that if you know the last term, if you know the last term, as long as you know the last term, right, then you can use the following formula. It's not like a must, but it's just saying, then you can use Sn is equal to N over 2 A plus L. You see, A stands for the first term, L is the last term, like the actual value. See, first term, L here, last term. You see, and then obviously in this other version here, N will be the number of terms that you're adding up. 2 formulas, they work for the same thing. One can be used all the time. The other one can be used if you know the first and the last term, because sometimes they may not give you certain pieces of information and only one can work at a specific time. So this is for, let's say, an arithmetic series. If it's a geometric series, right, it has its own formulas also, as you already know, and as has been explained already. If I have, let's say, here we're just adding 2 all the time, 2, 2, 2, 2, 2. But the moment I maybe have 2 plus 4 plus 8 plus 16, I now have a geometric series. It's geometric because we have a common ratio. You see, 8 divided by 4 is a 2, 16 divided by 8 is also 2. This is a geometric series, and already we know that with a geometric series will be equal to a r to the power of n minus 1, the whole thing over r minus 1. You see? So what we also know is that if r is bigger, is between -1 and 1, then you can also use this version. Both versions are fine. It's just something you can expect to see from, like, you know, your study guides and all that, like that. So this is this, you see. Now, with this being said, we know that this is still also a scenario where, I mean, as you already know, this is the general term. Nothing has changed here. So far with everything that I've said, in your mind, your mind is just thinking to itself, this is stuff that you know. The reason why you need to have that thought in mind is so that when sigma is introduced, you realize, wait, it's already something you already know. Because sigma is just a way of expressing that you want to add up terms in a series. That's all. Because when you have sigma, this symbol here means sigma. You see? When you want to add up terms in a series, you need to know where you're starting, like where in the sequence or series you're adding up from. You need to know where you're ending up. And then lastly, you need to know the formula, which is the general term. See? Because if you don't know the general term, then obviously, I mean, you cannot generate the sequence. And then sometimes you will not be able to see what is the common difference, what is the common ratio. You won't be able to see those things. So this expression will always be equal to Sn, you see. So whether it's an arithmetic sequence or series or a geometric series that you're dealing with, this expression will always be equal to a certain number that comes from you using this formula or this formula. That's the whole idea with sigma. It's literally an expression that will be asking for the sum of a certain number of terms. So your job with sigma notation questions is to just know what kind of a series are they talking about. Are they talking about an arithmetic series? Then you use one of these formulas. Or are they talking about a geometric series? Then you use any of these will work. This is just more to say in your study guides or whatever, you may see something like this, where these numbers are swapped, where these expressions are swapped. You see, if you swap the top, you swap the bottom, it's still fine. That's all that sigma says. You see, you'll have a general term that will generate a sequence. You will know where you're starting off to add numbers, and you will know where you're ending up. If you know that information, you will then also know, okay, it's a geometric series or an arithmetic series. Then you can use the formula.
What do you call Sn?
Sum of a certain number of terms. Sn just means sum of a certain number of terms. Just like Tn. Tn is the specific term, the specific number of a specific term in your series or sequence. S means the sum of a specific number of terms.
Oh, okay. Got it.
Yeah. So let's have a blunt example. Very straightforward example. You see, say we have a sigma expression here. They're saying here.
Oh, another question. What does TK stand for?
T what?
TK.
It can just mean the same as Tn. It's just a variable. Meaning, if they want to replace n here with k, they can do that. You see, it's just a placeholder. The only thing is that they normally use n, but if it's k, it doesn't matter. It's just a placeholder.
So can they also do it at the end SN and replace it with TK?
Like SK.
No, TK for SN.
No, the thing is there has to be a distinction of what is being asked or what you're trying to do. If you're trying to work out a specific term, then you can expect to have T with something. If you're wanting to work out the sum of a specific number of terms, then you can express S, you can expect S with maybe something. If you wanted to have SK here, I mean, like, that's up to you, because K here is just a placeholder for how many terms you'll be adding up.
Oh, ooh, now this is bad news.
Pardon?
I'm saying this is bad news.
Bad news, in what sense? Why is it bad news?
Oh, because my teacher has been telling us that it's TK, TK the entire time. So now I'm hearing the SN part. I just wanted to, yeah, ask about
Okay.
that. Yeah.
Okay. Yeah, well, at the end of the day, they are just placeholders. So it's not a big deal what someone wants to call it. It's really not a big deal. The big deal is knowing what the formula does and does it go with the question. Because sometimes people will be asked to work out the sum of something. Then you find them using a TN formula, either this one or whatever, which would be wrong, and vice versa. So as long as you know that this one is to add terms together, this one is to work out a specific term in the sequence, then you'll be fine. You get it? You get it?
Yes. You can carry on.
Cool. So the simple example that we have on sigma is you can have a sigma expression, right? Remember, a sigma expression is just them asking you a question without using words. You see? They can have let's say question 3 here without saying anything. They may not even say evaluate or whatever. They can just have the symbol, or they might say evaluate. They can just say maybe evaluate. If they are generous, they can just say evaluate, and then they put a sigma symbol here, right? Down here, they maybe say K is equal to 3. Up here, they maybe say 10. Here, they put a sequence. I like a general term, right? Let's maybe say 5K minus 2. You see? After they've just said evaluate. So here in translation, what they're saying is you need to work out the sum. You see, this is saying calculate Q, cow, Q, late the sum of terms in a series that is in a series generated. Here I'm just exaggerating, but I'm trying to make a point. Calculate the sum of the terms in a series generated by this formula or generated by this formula, right? Starting from T3, right? Or rather, let's make it easier. Starting from where K is equal to 3 until K is equal to 10. So what that means is you could have a sequence. Let's just maybe show that maybe this series, right, has like terms going, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, going on and on and on, right? Let's just say it carries on. This question, however, you see, this is position number 1, 2, 3, 9, 10, 11, going onwards. This
Mm.
question only wants you to add up.
Continue.
Pardon?
I have a question.
Mm-hmm.
So you see where n is, right? Where the 10 is, right? You said that if you scroll up, you said if, until k equals to 10. My question is, why don't they write k equals to 10 there instead of writing 10?
Because that's the thing. It just works hand in hand. The moment they put k is equal to 3 here, this automatically means that k has to end up at 3. They don't have to put k equal to 3 up there, because this number is linked to what's down here already.
Okay. Okay, you can
Yeah.
go.
Cool. So the terms that we'll be adding up here, according to this expression, is starting from here up until here. So if you look, the number of values you add up is actually 1, 2, 3, 4, 5, 6, 7, 8. You see, at a glance, you would have thought we're adding up 7 terms, which would have been wrong. You see, which is why this example is important, because this example is going to show you to always do things by the book so that you always get your marks. You're seeing here, we're actually adding up 8 terms. You see. Now, what is important for you to know is that when you're going to get an expression that just says evaluate, what you need to know is these 3 things. Firstly, you're starting to add up stuff from where k is a 3. You're going up until where k is a 10, and you need to know what kind of a sequence you're dealing with. So the easiest thing you can do for yourself, and this is something you can just remember so that you don't always have to crack your head for no reason. Anytime you see a scenario like this one, right? This can only be one of 2 sequences. If it is quadratic, then these numbers would not be too far apart. It just means you would need to work out terms added up together manually. Your formula, you would not need a formula for that. You would need to like see the term.
Like, can you like start again, but then from where you were counting the number of terms? Okay.
Yeah. So what we said was, if you look at what this expression is saying, it just says that we should add up terms starting from the 3rd up until the 10th one. From the 3rd to the 10th one, you're seeing that it's just 1, 2, 3, 4, 5, 6, 7, 8 terms, which is fine. We'll need that number just now. But what I was saying is, in this kind of a question, all you need to do is, if you get a question that is asking you to add terms in a series, before you do anything, remember, you just need to know that you're either going to use the SN formula for arithmetic or the SN formula for geometry. That's all you need to do. So you need to choose which formula to use based on your general term. You see, choose formula to use based on the general term. You need to choose which formula to use based on the general term. So for example, right, you...
How you so choose?
Pardon? Oh, choice. Oh God. Let's just move on. Yeah, thank goodness this is math. Anyways, so you need to choose a formula. Choose a formula. Choose a formula. Choose formula. Choose a formula to use. Yeah, let's actually just make it grammatically appealing as well a bit. Choose a formula to use, comma, based on the general term. So if you look at your expression, the general term, right? We said it is this one. You see?
Yes.
Now the
Mhm.
thing is, as long as the variable is not an exponent, you are dealing with a arithmetic series. I'll even write it down here. If the variable is not an exponent, then your series is geometric. There you go. Your series is geometric. Ka-chow. No. Arithmetic, bro. Come on. If the variable is not an exponent, your series is arithmetic. Just like this one, the variable is not an exponent, so you're dealing with an arithmetic series. You see, if k was an exponent, then you'd be dealing with a geometric series. Cool.
Okay. So
Yeah. So when you're looking at this already, you now know that all you have to do is you're using the SN formula for an arithmetic series, and you just have to work out the value of Sn based on the information you have. So you need a value for n, you need a value for a, you need a value for d. You see, that's the whole idea. So you can do this bit by bit. You can start with n. You see, n is always the following. This is where you need to know, you need to stay by the book. N is always where you're ending minus where you're starting, you always plus 1. You see, because if you just say 10 minus 3, you're gonna get a 7. But you're not adding up 7 terms, as we have just shown here. You're adding up 1, 2, 3, 4, 5, 6, 7, 8 terms. So that's why n always has to be n minus 1, n minus start plus 1. Forever and forever. You always have to plus 1. You already saw why you have to plus the 1. You see.
why do we need to start with the 1?
We're plusing the 1 because numerically speaking, 10 minus 3 gives us 7. But then between position 3 until position 10, it's 8 pieces of information, not 7.
Okay.
Because 1, 2, 3, 4, 5, 6, 7, 8. That's why you always say n is n minus start plus 1. So that deals with n. A, on the other end, A, you have to be very careful. Because A, we always assume it's term number 1. No, when you're dealing with sigma, A is equal to 5. A is what you get when you put the start. When you put the start, is A is what you get when you put the starting position into your general term. You see, that's what A is. So your A value in this situation is just 5 times 3 minus 2, which is equal to 5 times 3 is like 15 minus 2, that's like 13. And let's actually get a value here. We said it is 8 because 10 minus 3 plus 1 is 8. You see, so we have A and N. Does it make sense so far?
Yes.
Okay. So you see, N we have, A we have. D now, it's just a common difference. So you just need to find out the difference between 2 terms. It doesn't matter which 2 terms you pick, as long as one is ahead of the other. And you're saying the bigger one or the one ahead minus the one before. You'll always find your value of D like that. You see, so that's why D here, you can always just take any any position. It doesn't matter whether it's 2 and 3, 4 and 5, 5 and 6, it doesn't matter. So here you can even now just take D is equal to T2 minus T1. In your general term, you can put a 2 here, and then you can put a 1 afterwards. It's up to you. See? So you have 5 here, 2 here, and then you minus when you have a 1 there. Do you see? You see it?
Okay, I have a quick question. Okay, so basically, we put 5 in a bracket 2, right? Another bracket 1, right? Are we not starting with? Isn't it best to just put 3 and a 4, or sorry, a 4 and a 3 instead of that? Won't it affect the sum?
No. We'll actually do 2 and 1 now, and then we'll do 3 and 4, and then you'll see it's the same.
Oh, okay.
So here, this is 10 minus 2, because remember, this is numbers in the same sequence. So whether you use the difference between these two numbers, or the difference between these two numbers, or the difference between these two numbers, it doesn't matter, you see. The only thing is you're adding up terms starting from a specific place, going up until a specific place. But the properties of the series stay the same. You see, the common difference is still the same, whether you use 3 and 4, 1 and 2, 6 and 7. So I deliberately just used 1 and 2 because I'm trying to show that even though you're working with part of the series, the common difference is still the same. You see, so here we're getting what? We're getting like 10 minus 2, right? Which is like 8. So this is like a 8. Here, this is like 5 minus 2, which is like a 3. So this is like 5. You see, that's the value of D. If you had used position 3 and 4, like you said, then would have had like 5 with a 4 here. And then would have had here 5 with the 3 here. And then would have here 20 minus 2, which is 18. 15 minus 2, which is like 13. 18 minus 13, which is still a 5. But obviously, this is where you now get your freedom to say, oh, wait, so I can just use whichever one I want. 2 and 1, 1 and 3. I mean, 2 and 1, 3 and 4, doesn't matter, as long as one is just above the other. You get it? Yeah.
Okay.
You have a value of D, you have a value of N, and your value of A. So you can easily now just work it out. You see, in your SN formula, you can now just say S8, if you want, is equal to 8 over 2. A, we discovered it to be a 13. And then N is 8. D is a 5. The value of D, always use your brackets. Otherwise, your calculator will just form out and give you an error. So what is this in the calculator?
Two, multiplied by 2, I'm getting 244.
Pardon?
244.
Yes. There is your final answer. See. So this was to show that with sigma, it's just a way of asking a question that needs you to use one of the SN formulas. But you have to determine what kind of an SN formula you need to use. Once you determine the kind of SN formula that you need to use, then you're home free. You don't have to worry about anything else, because a sigma expression is just another way of asking you to work out the sum of specific terms starting from somewhere
Oh, okay. Can you put an example so I can tell you the steps so I can see if I clearly understand?
Yeah, that's a good one. Reduce